welcome to True Projects. In this video, we are going to explain about the project that is legal document similarity matching based on ensemble learning. Before getting into the execution, first let us understand what is the project about. In the legal world, the process of researching and comparing similar cases is crucial for making accurate and fair decisions. However, traditional methods we do have for matching the similar cases. But the thing is, they are extremely time consuming and prone to human error. Lawyers and judges, they often have to manually sift through hundreds of legal documents, searching for the cases with similar facts and legal principles. This can lead to inconsistencies in legal decisions as important precedents might be missed, or the same case might be interpreted differently or by different professionals. So this is where similarity case matching system comes in. So this uses artificial intelligence. So this SCM, that is similarity case matching, is it uses artificial intelligence to automate the process of analyzing legal documents. Instead of manually going through case after case, SCM system can quickly compare a new case with a database of previous cases based on key principles and facts. Here, by AI algorithm, they will be able to identify relevant precedents, ensuring that legal decision is consistent with past ruling. By doing this, SCM it helps to improve the accuracy and also consistency of legal outcomes, ensuring that decisions are based on objective evidence and legal principles rather than subjective interpretation. Additionally, SCM drastically reduces the time and also resources required for legal research, allowing legal professionals to work more efficiently and focused on applying the law correctly to each case. And the legal texts are very different from regular text. They are long, full of specialized language, and often contain complex terms that require deep understanding of the law to interpret correctly. Because of this complexity, traditional methods that we have, such as back of words, engrams, and TF-IDF, which are commonly used for text analysis, don't work well for legal documents. These techniques they mainly focus on counting words or phrases, but they miss the deeper meaning and connections between ideas that are crucial for understanding legal cases. For example, they might identify keywords but struggle to understand how those keywords relate to the fact or legal principles of the case. So, the recent advancements in the natural language processing and machine learning have changed this by introducing more powerful methods like transformer networks and deep learning based methods. These new approaches are much better at capturing the nuanced meaning behind legal text. They can understand not just the words, but also the relationship between legal principles, factual details, and outcomes of cases. This allows for more accurate and efficient legal analysis. And these methods can identify the key elements of a case and compare them with other cases in a much deeper way than traditional text matching methods. And ultimately, this leads to more consistent and reliable decision making. So, this project is for determining the similarity between legal documents, combining two key components, which are similarity representation subnetwork and binary classification subnetwork. The first part, that similarity representation subnetwork, it employs BERT model, that is the machine learning model, which is a type of machine learning model known for its ability to understand the meaning of the word in context. We use BERT embeddings to represent legal documents in a way that captures their deeper semantic features, essentially, the true meaning behind the words. To help the model learn better, we apply a technique called contrastive learning. This method encourages the system to bring similar documents closer together in understanding, while pushing non similar ones further apart. To further improve the model learning, we have used a technique called sampling long text segmentation, which artificially increases the data set by creating new samples, giving the model more data to learn from. And for measuring the similarity between documents, we use cosine similarity combined with softmax. This helps us precisely calculate how similar or dissimilar two documents are based on their semantic features. The key here is that the system doesn't just look at the words but understand the meaning behind them, ensuring that the similarity scores it generates are accurate and meaningful. And this process makes the system robust, capable of providing reliable results when comparing legal cases. And the second part of our system, that is binary classification subnetwork, takes over the task of determining whether two legal documents are similar or not. It does this by using the classifiers which are MLP, that is multi-layer perceptron, CNN, convolutional neural network, and LSTM, that is long short-term memory. These are different types of machine learning models, each with its strengths. The idea here is that after the first sub network has captured the deeper meaning of the documents, this classification step helps to finalize whether the documents are closely related or not. And what makes the system unique is that how both parts, that is similarity representation subnetwork and binary classification subnetwork, work together in an ensemble by combining representation based methods which capture the deeper meaning of the text with interaction based methods which focus on comparing pair of documents. We get more accurate and efficient result than traditional methods. This dual approach ensures that the system can reliably detect similarities between legal documents, helping legal professionals make more consistent and well informed decisions. It overcomes the limitation of older methods, which is often struggle with complexity and nuances of legal language. And to further improve the accuracy of this project, here we combine CNN, LSTM, and GRU. So here we have taken the classification model as a step further, introducing binary ensemble classifier. This new approach combines three powerful deep learning models that are CNN 2D, that is convolutional neural network, LSTM, that is long short-term memory, and GRU, that is gated recurrent unit. By grouping these models together, we are able to capture different aspects of the data and improve the accuracy of identifying similar legal documents. Essentially, each model brings its unique strengths to the table, and by working together, they provide a much more robust classification, outperforming the original and existing algorithms. And additionally, to the algorithm improvements, we have also built a front end interface using Flask. This is where legal professionals can interact with the system. This interface is designed to be user friendly, allowing easy access for testing and evaluating the system performance. To ensure the security, the interface includes secure authentication, meaning only authorized users can access it. This not only makes the system more accessible, but also ensures that data is protected and privacy is maintained. So, moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So, the first step is importing the libraries. First, we need to import all the necessary libraries and dependencies such as TensorFlow, PyTorch, and Hugging Face BERT for embedding generation, as well as libraries like Pandas and NumPy for data manipulation. Then comes data preparation. Here we collect the data set containing legal case details from sources like Kaggle or the other legal repository. So here we took the data set from Kaggle repository. And then we pre-process the collected data by cleaning the text, that is removing unwanted characters, standardizing the text, and extract relevant field case details text, which will serve as the input legal document for further processing. And then comes embedding generation. Here we load pre-trained BERT embedding model to convert legal text into semantic vectors. These embeddings capture the meaning and context of the documents, making it easier for model to understand underlying principles of legal text. Then comes similarity calculation. We compute the similarity between document pairs and use cosine similarity, a metric that measures the angle between two vectors to assess their closeness. After that, we apply softmax function to normalize the similarity scores and a loss function to minimize the distance between similar documents while maximizing the distance for non-similar ones. And then comes data augmentation part. Here we use sample long text augmentation to generate synthetic or augmented data. This technique helps to expand the dataset and improve the model's ability to generalize by creating variations of existing documents. And coming to binary labeling, here we assign binary labels to document pairs based on predefined similarity threshold. Similar documents are labeled as 1 and non-similar documents are labeled as 0. This helps the model to learn and to distinguish between similar and non-similar pairs. Then comes train and test split. We split the data into training and testing sets. The training set is used to train the model and the testing set is used to evaluate model's ability to generalize on unseen data. Then comes model building. Here we define the architecture of the models by combining similarity representation subnetwork using BERT for feature extraction and the binary classification subnetwork for classifying document pairs as similar or non-similar. Then comes model training. Here we train the model using training dataset. During this phase, the model adjusts its parameters to minimize errors, learning to recognize patterns and classify document pairs correctly. And all the models which are trained, they are evaluated. And then comes the front end part. So we built a user-friendly front end using a Flask framework. The front end allows legal professionals to interact with the system, input legal documents, and receive similarity predictions in a simple, intuitive way. And we implement a user registration login system to ensure secure access to the system, use credentials that are stored securely in a SQLite database, ensuring that only authorized users can access the system. Then comes user gives input. So here, users they will be giving input as a text. User they can input legal documents or case details through the front end. These inputs will be pre-processed to check their similarity with the existing database for legal documents. And that input will be pre-processed at the backend. So the system pre-processes the user input by cleaning and tokenizing the text. This prepares the input data for prediction by converting it into the necessary format for training the model. Then comes the prediction. So train model will be used for predicting, and that will be displayed through the front end of the application. So this is how we have implemented the project. Moving on to the algorithms used. These are the algorithms used in this project. And this is the extension model CNN 2D LSTM GRU. And here are the requirements. To implement this project, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, and RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, and database of SQLite 3. And front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let us execute. To execute, we are supposed to open the code folder which contains source code files. Let us open the code folder. So these are the source code files in the code folder of a project. Let us understand each of them. How will they be used in this project? Here in this folder, we have dataset that is used in this project. So this is that file. Open that. It is being loaded. Just wait for a while. So here we got the data. So this is the case ID, and here we have case outcome, and here we have case title 2. So this is the case title and this is the case text. Here we have total 24,976 case text that we will be using model to train for checking the similarity between the cases. Now let's close this. And here in this test data file, we have test cases that we will be using in the front end for checking the similarity between cases. Let's get back. And here in this model folder, we have the algorithm information that is stored in .h5 files, numpy files, pickle files, etc. And that will be loaded into the project code during runtime. And coming to the static folder, this folder consists of files related to CSS, JavaScript, Bootstrap files. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have a sap.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have as a notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. So this is about the code folder. Now let us execute. Copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the command prompt. So it has been opened. Give the command cd, give the space, paste the copied path, and now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and now click on enter. So this command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So just wait for a while. A whole localhost will be generated. So here localhost has been generated. This is the localhost and this is the port. So this is the address where the website has been hosted. Now let's copy this local link provided by the Flask framework. I have copied it and pasted it into any web browser. I prefer Chrome, so I will paste it in that. Paste the link here. Click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So sign up first, click on sign up and enter all the registration details if you are registering newly. I have already registered, so I will directly sign in. Click on sign in and give your username and the password. So give your username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. Here you can see choose file button, right? We need to click on that for uploading the test case file. Click on choose file. This is the file that we are supposed to upload. Select it and click on open. Here it has been loaded. Now we are supposed to upload. Before uploading, let's see what do we have in that test data file. So get back to the code folder, open the data set and open the test data. So here are different test cases that we will be uploading now, and these are of three features, that is case outcome, case title, and case text. These inputs we will be giving them. So that is to the application. After we give these text, it will match with a similar case. Let's close this, get back to the application, click on upload. So this given input, it will be pre-processed at the backend, and then it will be fed to the train model. Then train model will be giving us the prediction. So this is the first case that we have given. So this is the first text data, case text data. And here we got the prediction that no matching similarity found. So for this case, there is no similar cases found. And for the next case, this is the second case that we have given. For the given second case here, document similarity matched with case one. So this is similar with the case one case. So this is the case. This is matching with the case one. Similarly, for the third case, so this is the third case that we have given, and that is matching with the case 12. And the next fourth one is matching with the case 1344, that is 1344. And the next one is also matching with the 1344. And the next one is matching with the 1343. Similarly, for all the given cases, here we got the prediction, that is with which case it is being matched. If it is not matching, it is showing that it is not having any similarity found, no matching similarity found. Now let's check with the graphs. Click on graph. So here, the first graph which we have is the extension models confusion matrix. This is the confusion matrix of CNN 2D LSTM with GRU, and this is the RSC AUC curve graph, where on x-axis we have false positive rate and on y-axis we have true positive rate. And here we have accuracy score comparison graph. Here on x-axis we have accuracy score and on y-axis we have all the algorithms that are trained. And this is the precision score comparison graph. This is the recall score and this is the FN score. Accuracy, precision, recall, and FN score are the metrics used to evaluate all the classification models. So that is why we have used those metrics into this project. Now let's sign out. Click on sign out. So this is all about this project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.